Hey guys, we're going to be doing more FP2 today, more maths. We're looking at AQA Jan11 question 6. It's about differentiation and integration. And I'm going to be sort of focusing a little bit on this video. How should we lay our answers out? How do we make sure that if we know what we're doing, the examiner gives us all the marks and the examiner doesn't have to really look to give us the marks. The marks should be jumping out of the page at the examiner. That's what we want. So question 6. We've got x here that equals the natural logarithm of sec t plus tan t minus sine t. And you can begin writing the question like that. I always take what's in the question, I write it on my page, and it's a show that question as well. So what you might want to do, so your eyes don't have to keep on jumping back to the exam, is just after here, write want to show, WTS, that dx by dt is sine t tan t. So I've got my question, I've got what I want to show. I shouldn't have to look at the exam paper again. Maybe just check out that it's 4 marks. So I know I need 4 separate steps, but other than that, I don't need to look at the exam question anymore. Okay, so we need to differentiate this then. So dx by dt. And we've got a function inside another function here. So we're going to use the chain rule. So that's the derivative of the outside function multiplied by the derivative of the inside function. So when we've got ln x, say, the derivative of the inside function is 1 over x. The derivative of ln is 1 over whatever is inside the brackets. So the derivative of this is 1 over sec t plus tan t multiplied by the derivative of the inside function. So I don't have to put that on the top of the fraction, I can write multiplied like this, and then in a bracket, the derivative of the inside function. So the derivative of sec t plus tan t. The derivative of sec, I don't know off the top of my head, it's in the formula booklet though. The derivative of sec is sec t tan t. And the derivative of tan is sec squared. And then we have to differentiate sine t as well, which is cos. So the whole thing minus cos t. Cool. And now I've got to get this whole thing to sine t tan t. Okay, how are we going to do that? Next step then is we can have a look inside this bracket here. And I think at this point I will bring the bracket on top of my fraction. We can factorise out sec t out of here. Now, with lots of these show that questions, you're either thinking 2 different ways. You're sort of thinking, either how can I get to this answer, or what's the only thing I can do next? And towards the end of this question, I mean, this even happened now really, towards the end of this question, we are going to be thinking, what's the only thing I can do next? So we look at this and think, what can I do next? Oh, one thing I can definitely do next is factorise this sec t outside the bracket. So sec t multiplied by tan t plus sec t over sec t plus tan t. And then we've still got to minus that cos t. Cool. So at this point now, the next thing to do is kind of jumping out at us. We can cancel the tan t plus sec t with the tan t plus sec t on the bottom. So this cancels out with this, and we're left with sec t minus cos t. Now at this point, we're looking at our answer. Our answer is sine t tan t. I'm not really sure how I'm going to get that to sine t tan t. I don't know how it's going to work. I definitely can't see the steps in my head. So I need to think, what's the only thing I can do next? Or what can I do next? Really, the only thing we can do next is rewrite sec as 1 over cos. So let's do that. And there's a cos here, which kind of suggests that's a good idea anyway. So 1 over cos t minus cos t. Okay, what's the only thing I can do next? It's getting a little bit harder. I've got a fraction here, and I've got something that isn't a fraction. Quite often when we see that, if we've got a fraction added to something else or take away something else, we want to combine it and we want to make it one fraction. So let's do that here. How can we do that? Let's make this denominator cos t as well. So we're going to multiply top and bottom by cos t, and that's going to give us cos squared t on the top. Now when you do this, remember I'm talking about how to lay things out. I've gone to the right here. I've sort of written this line and I've gone to the right to write my next line. That's just to fit it on the board. When you do this, each new equals should be a new line on the left here. So ideally this should be down here, but I would have run out of space if I did that. So I'm just going to carry on here. I've got 1 over cos t minus cos squared t over cos t. And now I can combine that fraction. So on the top, I've got 1 minus cos squared t over cos t. And 1 minus cos squared t, that's great. That's exactly what we want to see. It's the most, the classic trigonometric identity that we all know. It's the only one that we remember. Sine squared plus cos squared equals 1. So 1 minus cos squared is sine squared. So we're left with sine squared t over cos t. And now, this is where kind of the other technique comes into play. Now we look at our answer. We can look at our answer. We've got sine here, sine, but how do we get tan? Well, tan is sine over cos. So let's split this up into sine and sine over cos. I think, despite my best efforts, I've run out of room anyway. So I'll quickly jump back up here to finish it off. So we split this up to get our sine and to get our sine over cos. So it equals sine t multiplied by sine t over cos t. And that is sine t tan t as required. Cool. So split your workings out, do it one line at a time. And with these trigonometric identities, either have in your head, well, what can I do next? What's the only thing I can do next? Let's do it, let's try it, let's see what happens. Or look at your answer and try and bridge a gap between where you are and where the answer is. And we've seen in some of these other episodes how we can even sometimes look at the answer and start working from the answer and try and meet in the middle there, which is quite cool if you can do that. Okay, so the derivative of this whole thing is sine t tan t. That's going to come into play in the next question, part B. Let's take a look at it. We're integrating along a curve, finding the length of the arc. Formula for that's in the formula booklet. And the curve is defined parametrically. So we've got the same x is in A, that's going to help us out quite a lot, and y is cos t. So as you can see, the curve's been defined parametrically with x coordinates and y coordinates. Find that the length of the arc curve is the ln of an integer. Fair enough. So if you go to your formula booklet, and again I would write down this formula just so it stops you from having to look at the booklet. The arc length when we're using parametrics is the integral of the square root of dx dt squared plus dy by dt squared with respect to t. Yep, so write it down, you don't have to look back. Let's jump in. Okay, so the integral of the square root of dx dt squared. We know what dx by dt is from the last question. Dx dt is sine t multiplied by tan t, and we've got to square that. and then we add on dy by dt squared, which is minus sine t squared. Derivative of cos is minus sine, and that's between the limits 0 and pi on 3. Those are the question. Cool, and so we've got to get that whole thing to ln of an integer. So this is the integral between pi on 3 of 0 of the square root. Let's square this bracket, sine squared t tan squared t. The minus, when we square it, just disappears, so that's plus sine squared t. I can see one good thing to do next. I can see that I can factorise out the sine here. So let's do that. Just seeing if I've got another pen that shows it. No, definitely not that one. Is that any better? Maybe I'll switch. Cool, so let's factorise out the sine. So the integral of the square root of sine squared t multiplied by tan squared t plus 1. And any sort of trigonometric squared plus or minus a 1, or like 1 minus tan squared, whatever, that should be firing off alarm bells. Let's go to our basic trigonometric identity. That's sine squared t plus cos squared t equals 1. How can we get a tan squared out of that? Because we want tan squared there. Sine squared over cos squared is tan squared, so let's divide by cos squared, and that tells us that tan squared t plus 1 is equal to sec squared t. So that's what I'm going to write in the next line. I'm going to swap that tan squared t plus 1 for sec squared t. So our arc length S, the integral between 0 and pi on 3 of square root of sine squared t sec squared t dt. Sec squared is just 1 over cos squared. So sine squared over cos squared, that's tan squared. Square root of tan squared is just tan. Again, I'm being a little bit cheeky, I'm staying on the same line. What's the integral of tan? I've got no idea. Why are you asking me? Let's go to the formula booklet. Integral of tan is ln, great, we want a ln, ln of the modulus of sec, which is 1 over cos. So we want square brackets now because we have integrated. Ln of the modulus of 1 over cos t between pi on 3 and 0. So that is ln of 1 over cos pi on 3 minus ln 1 over cos of 0. And we're pretty much there. Cos of 0 is 1. 1 divided by 1 is 1. So the ln of 1, well, what does the ln of 1 mean? That means e to the power of what is equal to 1. And that's 0, because e to the 0 is equal to 1. So this whole thing is 0, so we don't worry about that. Cos of pi on 3 is a half, and 1 divided by a half gives us ln of 2, which is as required, because that's ln of an integer. Cool, okay. I got my first comment last week. That was great. That was really exciting. Keep them coming, guys. Any comments about what I've just done, about life in general, whatever. Just put your comments on YouTube under the video, and I'll read them. I'll definitely read them. That's for sure. Let me know if you want me to do any more questions. Yeah, that's about it for me. Cool. Good luck. Yeah.